Okay, for part B, we have to evaluate this definite integral with the function that is the modulus function. So let's try to simplify this function first and try to get it within the limits. So if I set x minus 1 is equal to 0, which gives me x is equal to 1, and the next modulus function is x minus 2, let's set it to 0, which gives me x is equal to 2, and x minus 3 is equal to 0, which gives me x is equal to 3. So that means I can divide or write this the definite integral for 1 to 3 as 1 to 2 and then 2 to 3. So this is our function. Our function is f of x is equal to modulus of x minus 1 plus modulus of x minus 2 plus modulus of x minus 3. Okay, and we have we are going to value this function for the values x is greater than equal to greater than 1 but less than 2. So x is greater than 1 but less than 3. Sorry, 2 for the first interval. So for this interval 1 between 1 to 2, x minus 1 will be, this x minus 1 will be, because the value of x will be less than 2. So this x minus 1 x is greater than 1. So this value is always positive. So x minus 1 is positive. Now x minus 2 for values x is greater than 1 but less than 2. So this value will always be less than 2. So that means this is negative. And this value for x, this value will always be less than 3. So this is also negative. So this function now reduces to negative of x minus 3. So this is equal to x minus 1 minus x plus 2 minus of x plus 3. So this gets cancelled, and finally we have 3 plus 2 is 5, and 5 minus 1 is 4. So this is 4 minus x. So that means this function is reduces to 4 minus x for the first interval. Now let's evaluate this function for the values for interval 2 to 3. So between 2 and 3, this value is always greater than 1. So that means this is positive. This value is always greater than 2. So this is also positive. And this value will be for the interval 2 to 3. This value for the x will always be less than 3. So this value is negative. So this is negative of x minus 3. Okay, now if I go ahead and open this, so this is x minus 1 plus x minus 2 minus x plus 3. So x and x gets cancelled, and this value, okay, so finally we have this is minus 1 minus 2 is 3. So this is equal to x minus 3 plus 3, which reduces this function to x. So that means I can write this definite integral that is as uh, an integration of two intervals, that is 1 to 2, for which the value of the function reduces to 4 minus x into dx, and this for 2 to 3, this function now becomes x. So this is x into dx. Now let's evaluate it. So integration of 4 is 4x minus x squared by 2, and we have to evaluate it for the limits 1 and 2. This integration of x is x squared by 2, and we have to evaluate for the limits 3 and 2. So let's evaluate it for the limits 2 and 1. So this is put the value of the upper limit in the function and subtract this value by putting the value of the lower limit in the function. So this is 4 into 1 minus 1 by 2 plus. This is once again putting the upper limit. This is 3 square by 2 minus lower limit 2 square by 2. Okay, if we go ahead and simplify this, so 4 to 0 is 8. So this is 2 minus 4, and this becomes 3 square by 2 is 9 by 2, 2 square by 2, this is 2. Okay, so finally we have 8 minus 2, 6 minus 4. 8 minus 2 is 6, 6 minus 4 is 2, and 2 and 2. So this gets cancelled. 8 minus 2 is 6, 6 minus 4 is 2. So this gets cancelled with minus 2, and finally we have half plus 9 by 2, which is equal to 10 by 2, which is 5. So we have evaluated this for the value 5.